Hello, everyone. My name is Sean Morrissey. I'm an application engineer with Alpha Omega Product Development Systems. And in this video, we're going to be going over the different ACT extension tools within HFSS, specifically the Antenna Toolkit. The HFSS Antenna Toolkit is a powerful tool for antenna customization, providing flexibility to select the desired frequency, substrate material, and type of antenna. The Antenna Toolkit is a very useful tool if you are doing anything from checking your own calculations to having a foundational design to base your antenna off of, or even to have a pre-generated model incorporated into the design you are currently working on. So with that, let's get started. So first, you're going to want to open up HFSS, go to the automation ribbon. Well, even before that, open up any HFSS file, then go to your automation ribbon. You're going to want to show your ACT extensions. And let's not get too ahead of ourselves here. The first window that's going to pop up is the ACT Home. From here, you can manage your extensions and launch wizards. In this video, we're only going to be going over the wizards and again, only particularly the HFSS Antenna Toolkit. But we will be touching briefly on what the 5G wizard, what the HFSS EMA 3D data link, and the Maxwell eccentricity wizards. I'll touch on those briefly, what they do, but again, the sole basis of this video is on the antenna toolkit. So as you can see here, you have a bunch of different antennas that you can customize. And the neat thing about the antenna toolkit is that it synthesizes the antenna dimensions according to the operation frequency, which is, as you can see, for just this regular wire dipole antenna, you can change this to be whatever you need it to be. Let's say we're going for, it's 10 gigahertz, say 10 gigahertz antenna, press synthesize, and it calculates the antenna dimensions for you. So you can see the different types that you got here. You have bow tie, conical spiral, a few custom antennas, dipole, helix, horn, log periodic, miscellaneous. You got your bicone, discone, monopole, PIFA, patch antenna, planar spiral, reflector, slot antenna, Vivaldi antenna, even waveguides and Yagi antennas. You can also have your own personal library antennas equipped to this. However, we'll just be going over the preloaded ones here. So, for example, let's start with a Helix antenna. So we're going to start with the Helix. Let's pick its axial mode. And if you don't know, the axial mode of a Helix antenna essentially describes that the direction of propagation is along its axis, and it's got the maximum directivity that a Helix can have. Helix antennas are really cool. They're naturally circularly polarized. What's really cool about the calculator is that it gives you all different types of dimensions from the antenna itself to the feed and even the ground plane. It gives you a little model here to show you exactly what each of these parameters correspond to and even where the equations are derived from. This is from Bolanis' great textbook. For Helix as well, there is a textbook by the creator Kraus. Highly recommend that one. That's one that I've used to design different antennas in the past. However, let's stick to that 10 gigahertz at the center frequency. We're going to insert 10. We're going to synthesize. And you can see that the parameters updated. So then from here, all the parameters have been calculated. So now we're going to finish. And what it's doing is that it's creating a new project and it's preloading all the results and even preloading the model. So you can see here we have our axial Helix antenna, and it's designed everything from the ground plane to the feed as well as the Helix itself. We can open up our model tree here, and we have our PEC, and the Teflon of the coax. So really neat tool right off the bat, just looking at it. You can see that it sets up the boundaries, already does the port for you, has different results pre-generated here, and even the solution. So we're going to go ahead, we're going to analyze all. While that runs in the background, let's touch on what some of these other wizards do. So we have our 5G wizard here. I can go ahead and click on that. Really, what the Ansys 5G wizard tool is used for is for calculating power density or CDF, cumulative distribution function. So really nifty. All you need to do is insert your BeamID codebook with a codebook that you have already to supply. So let's go back here. Gives you some more information. We're gonna exit the wizard. EMA 3D is really helpful if you already have an antenna designed and you want to save the fields of that antenna. And that can be used to export to some complex cable modeling design that you have going on with an antenna integrated. So if you want to transfer those fields to AMA 3D, then this is the tool for you to use. I won't be able to actually open up Maxwell because this is not a Maxwell transient design. Essentially, what it does is that it allows the user to evaluate the effects of misalignment, such as variations in the air gap magnetic fields, which is really vital for optimizing motor efficiency, and longevity. So a bunch of really useful tools supplied by Ansys to be able to make the integration of your different projects or designs just flow smoothly, help you out as best as you can. So we don't need to look at the toolkit anymore, so we can go ahead and just close out of this window. And you can see here that the simulation has completed. We can look at our different gains here. That doesn't look too axial. So you may have to play around. The toolkit provides a great foundational layer for you to get started with your design. Now, there could have been a value that I had missed before. However, it's all a part of the design process. I mean, these things happen. You can look at our Smith chart here. Yeah, no, so something definitely, it seems that I may have missed a value there, but that's all right. You know, as a part of the process, these things can happen. So say this happens to you, right? You missed a value, or say you have all your values inputted correctly. However, the antenna, based on those calculations, aren't exactly quite what you expect them to be, or you need to tune it to the correct operating frequency. We can go ahead and jump to optometrics. You go to add, you add parametric. Actually, before we do that, what I love the most about this tool is that when we go into design properties, everything's already automatically put into a variable for you. So it's even categorized nicely here. They're all named appropriately. So number of turns, let's focus on number of turns. If we go to our return loss, we can see we're not quite at 10 gigahertz. There's a small resonance dip there. Seems it's more appropriately matched for this frequency here. Let's see what this is, just out of curiosity. Bring this over here. It's around 14 gigahertz, so not quite what we wanted to be at. Again, things like this can happen. So let's go back to optometrics. And what this tool allows you to do, and I'll be going over this a little bit more in depth in another video, you select the variable you want to alter. So here let's do number of turns. and it tells us that the value it's currently at, the nominal value, is 3.341 turns. So let's start at, it takes that as the halfway point and creates a range automatically based on that. Now you can change these numbers to be whatever you want. For me, I'm going to keep it as that. I'm going to add a step value of 1. We're going to go ahead and add that. I'm going to press OK. So what's going to happen here is that it's going to analyze the model 5 different times based on those start and stop values. And it's going to produce each of the results we have generated, however, at these number of turns respectively. So we're going to have 5 different results in our graphs, as well as an additional one for the nominal value that we already had generated. So I'm going to press OK. And you can see we have our parametric value set 1. If you'd like, it's always good in case you have a few different parametric sweeps that you want to go through. It's good to just rename this. So I'm just going to rename this turns. You can do number of turns, probably better. However, turns will suffice for now. And you are going to, it's always good to validate for you analyze. I know the validation is going to be okay here because geometrically, nothing should be interfering with the values we have selected. So you can already see that we are A-OK to run this. So I'm going to go ahead, right click on turns, and we're going to press analyze. So what this is doing is, as I previously said, it is going to grab all the different values that we defined earlier in our parametric sweep and apply them to the model and go through our solution for each of those number of turns in that model. So skipped ahead a little bit here. This is currently on its 3rd value. So right now it is running for 3.67 and just completed. So now we're on the 4th step. So this is a pretty simple sweep. Nothing too crazy. However, you can have multiple different values. So say if we did number of turns and we changed the diameter for each individual value, say we had 3 different values inserted for the diameter. We did 1 centimeter, 2 centimeters, 3 centimeters. For 1 centimeter, it would go through each individual variation of the number of turns, and then the same for the next. So in total, there would be 15 sweeps there. So it can get pretty convoluted pretty quickly. However, this is a great tool to realize different trends in what changes the parameters of your antenna by, for instance, with the Helix, increasing the number of turns. What does that do to our return loss? We're going to find out in a minute here. Great way to characterize your antenna is what I'm getting at with that. So parametric sweep is a great tool to utilize, especially if you're trying to understand the fundamentals of well-documented antennas. So great tool to just play around with for your own knowledge. So now our parametric sweep has finished. When that's done, you go to your the results you want to change. You go to the variable that the sweep ran through, use all values, apply trace, and you can see how the parametric sweep affected your file. Thank you so much for learning about the antenna toolkit with me today.